Now let's get back to some more user-defined types or classes. First, let's look at this class I made right over here. Right after using namespace std before the definition of the main function, I declare this class solder, and let's have a look at what member variables it has. I usually like to put them on the bottom of the class declaration. So over here, as you see, I made them private. I have one int health and one int strength. And let's take a look at what methods I made. This is one that doesn't return anything, it's void, and I call it attack. And as we see, what it does is it prints out that we're attacking with, then we bring up the variable strength, and then we say that that's how much strength we're attacking with. Now the first thing to notice over here is the rules of scope have changed a little bit. In a regular function, I would get a compiler error complaining that we don't know what is this thing over here, strength. This function hasn't declared a variable strength, and no variable strength has been passed in from any other function. So what is this thing over here? Strength. Well, as you've guessed, in classes, every single one of the member variables are considered to be existent inside the scope of every single one of these methods, of these functions. So automatically in this function over here, in this method, we automatically know what strength is, and in this function over here, we automatically know what health is. This function over here, I called it heal, which of course will heal our wounded soldier. And of course this variable over here was not declared part of the class soldier. There is no member variable called amount health. So the only way we could know about such a variable in this scope, in this function over here, in this method, is if we declare it. And in this function, of course, we declare it right over here in the parentheses when we declare that this function, anytime it's called, it will be bringing in a integer type of variable to which we are giving it our local name, amount health, as we learned about passing variables into functions. So of course when this function over here is done, amount health will disappear, it will be destroyed, but on the other hand health will continue to exist as long as our instance of the class soldier exists. Of course, don't forget that we aren't really thinking about the class soldier. We are always thinking about specific instances of the class soldier that we will be making in our program. So I will be making soldier A and soldier B and stuff like that in my program. Each one of these soldiers will have its own health and its own strength, because that's what I declared over here in the declaration of the soldier class, that each instance of this class will have this stuff. So as long as these instances, this soldier A and soldier B still exists, so do their member variables also exist. Then we have another function which makes the soldier be attacked, and over here we print out how he's screaming, and we are taking off 1 point of its health. And one last method, getHealth, which provides anyone who will be using this soldier class with the possibility to get the actual number of the health variable, which is really private. As we learned, you can't access private members. You will have to get their values using such type of public functions. Let's try to use all of this a little bit. Here in our main function, I start off by creating a soldier called A. The A will now perform the attack method, which is public. It's a public method, so I can just use the simple dot operator to execute A's attack function. Or let's just call it John for clarity's sake. So I created John right over here, then I made John attack, then I made John be attacked by calling this method over here, which is also public. Then I healed John with his heal function, and of course I remembered that I made heal function take a integer variable along the way. That's what we declared right over here. The interesting thing is that I don't really have to pass in a actual variable that I created from before. I can even pass in a regular R value, like the number 3 right over here, and this gets successfully passed as a integer variable, which is then of course copied into this variable over here, amount health. So in this particular case that I called the heal function, the heal method, and I passed in 3, then of course the heal function right over here, this variable amount health will have the number 3. And finally over here, I call the get health function because I want to know how much health is inside of John over here. Excuse me, I didn't fix that one over here. And since it turns out to be an expression because it returned a actual variable, as we said right over here, because we made it integer return value, return type, and we returned the health variable declared right over here in the class. So I take that expression that came back from this function over here and I put it inside of a integer x. Now here's a big problem with this program right over here. We forgot about a basic rule of the integer variable, and that is that if you start using a integer variable without giving it a number first, like if I do this right over here, I create the variable f, and then without giving it any number, I make the program add 1 to the variable when we don't even know how much f has to be able to add 1 to it. That will cause a runtime error when you try to use a variable that you never gave a number to. The problem is that when we created John right over here, as soon as an instance of a class is born, all of the member variables are also born right over there. So as soon as John was born, along with him was born one integer called health and another integer called strength, which both belong to him, to John. But these variables were never given a number to begin with. Then when we call the attack function and we start using the variable without first giving it a number, like over here we try to print it out to the screen, that will not cause a compiler error, that will cause a serious runtime error. And unfortunately the solution is not to go right over here and to give it a number to start with, because over here you only have the declaration of this class's member variables. You do not have any assignment of values whatsoever, only the declaration. So how do we make sure that every time I create a John, I won't cause any runtime errors by someone accidentally using a function which uses one of the member variables without them first getting some sort of starting point number? One idea would maybe be to create your own little function, which would be called something like start, and this function start will give some sort of starting point number to our class's variables, and then we would hope that every time someone uses the class soldier to make an instance like John, the law would be that you have to call first John's function of start, and only then can you continue using an instance of the soldier class. Well, that would definitely solve the issue, because now every time when you create a soldier and you remember to call the start function, the member variables will now have some sort of starting number with which they could now work further on in other functions that use the variables. The problem is that this type of design of classes, that you hope that everyone who uses your class, including yourself, will always remember to call the start function every time they make a soldier, that's very bad design, and you don't want to depend on such an assumption that everyone will remember to call this start function. So we would really like some magic that only by just creating a soldier like this, just like that already, somehow the variables should have a starting point number. If you make the member variables constant, by the way, then you would have to right away give it a number right over here in the declaration of the class. But of course, in such a case, none of your soldiers will ever be able to change the amount of its health and the amount of its strength, because constant makes a variable stay what it is for the rest of its life. So all of our soldiers will always have 9 health and 10 strength. So how do I give starting numbers to my member variables immediately when an instance of my class is created, so that I won't have runtime problems of using a variable which was never given a number, a value.